Example 4. Our last example is a combination of all the things we've looked at in the other examples here. So again, we're talking U-substitution, right? So I'm going to start off with 3x minus 1, right? That quantity to the third power, that'll be my U value. So I'm going to come over to the side here. U is equal to 3x minus 1. And I'm going to go ahead and skip a step here just to save us a little bit of time, right? I'm going to write du is equal to 3 dx. And then I'm going to say 1/3 of du is equal to dx. So again, u is 3x minus 1, dx is equal to 1/3 du. Now, real quick, in the last example, right, I did not solve for dx by itself, but I am this time, right? What's the difference? Well, the difference here is that I have dx in my integrand, or excuse me, times my integrand, right? But the derivative of u was just 3, and there's more than just that here, right? I have another variable, and so this is going to bring it back to examples 1 and 2, right, where I need to solve for x using my u value. So add 1, divide by 3, and I'm going to get u plus 1 all over 3 is equal to x, and that'll be my substitution in for that variable. Okay, and then the last thing I need to substitute for are my limits of integration. So I have 1 and 1/3. Remember, these are in terms of x, so I'm going to plug them into my formula for u. So I'm going to get that u is equal to 3 times my upper limit of integration is just 1, so 3 times 1 minus 1 is going to give me 2. So when x is 1, u is 2. And then when x is 1/3, so u equals 3 times 1/3 minus 1. Well, 1/3 of 3 is 1. Minus 1 is going to get me 0. And so when x was 1/3, u was 0. So my limits of integration for u are now going to be 0 for the lower limit, 2 for the upper limit. So let's go ahead and substitute everything here in terms of u. Okay, so my lower limit of integration is 2, or excuse me, is 0, pardon me. The upper limit of integration is 2. I can replace x with u plus 1 over 3 minus 1/3, and then I'm going to have u to the third power times 1/3 du. So new limits of integration, new value for this x, new thing to the 1/3 power, and then new differential here at the end. Instead of dx, I get 1/3 du. So another complete u substitution, okay? All right, so let's go ahead and try to simplify this. So first thing I'm going to do is bring the 1/3 away from the du and bring that out. Limits of integration are still 0 and 2. And now in this parentheses here, right, before I distribute the u cubed, I have u plus 1 divided by 3. I can split that up into two fractions. I can split that up into u over 3 plus 1/3, which is very convenient because right next to it, I have a minus 1/3. Meaning those are going to cancel each other out. So I have u over 3 left over times u cubed du. And now u over 3, that's another 1/3 that I can bring out and multiply it with the 1/3 that's already there. So I get 1/9 times the integral from 0 to 2. U times u cubed is going to be u to the 4th power du, and this becomes a very nice integral for us to do. So this is going to become 1/9, right? 1/5 u to the 5th power, plugging in 0 and 2. And now 1/5 times 1/9 is 1/45. And when I go ahead and plug 2 in for u, I get 2 to the 5th power. And when I plug in 0, well, that whole part's going to drop out. 0 to the 5th power is 0. So it's just 2 to the 5th power, which is 32. So I get 32/45, and that's my final answer. Okay, so another complete U substitution here, all right? And that'll do it for us. So I'll see you next time.